Jeff Bezos spent $10 billion in 24 years building Blue Origin. 0 commercial satellites delivered. Rocket Lab, with just 1,500 employees, launched 68 missions with 94% success rate and just secured NASA's $5.6 billion defense contract. The numbers don't lie. Blue Origin's New Glenn has failed twice this year alone, while Rocket Lab pulled off back-to-back launches in 48 hours. Even SpaceX is watching nervously as this small company breaks ground on Launch Complex 3 for their game-changing Neutron rocket. How did the underdog crush the billionaire's space dream? Let's dive right in. The answer lies in a series of events that unfolded over the past year, revealing just how far Blue Origin has fallen behind. While Jeff Bezos was planning his $30 million Italian wedding, his space company was experiencing its most embarrassing failures yet. On January 16, 2025, Blue Origin finally managed to launch New Glenn after 4 delays. The mission seemed successful until the landing attempt. 3 of 7 BE-4 engines failed to reignite, sending the $100 million booster crashing into the Atlantic Ocean. For a company that promised orbital flights by 2021, this wasn't just a setback, it was a pattern. Meanwhile, something remarkable was happening in New Zealand. Rocket Lab achieved what Blue Origin couldn't: consistent, reliable launches. Their June 26th and 28th missions proved that operational excellence beats massive budgets. 2 perfect launches in 48 hours from a company with 7 times fewer employees. This wasn't luck. It was the result of fundamentally different approaches to aerospace engineering. To understand why Rocket Lab is winning, we need to examine the technical choices that separated these companies from the start. Blue Origin chose complexity. Rocket Lab chose reliability. Blue Origin's BE-4 engines took 13 years to develop and still fail regularly. Each engine costs over $10 million and requires extensive refurbishment between flights. The complexity shows liquid oxygen and liquid methane propellants, intricate turbopumps, and systems so sophisticated they break under real-world conditions. Rocket Lab took a different path. Their Rutherford engines on Electron use proven RP-1 and liquid oxygen, simple, reliable, and battle-tested through 68 successful missions. When they designed the Archimedes engine for Neutron, they learned from Blue Origin's mistakes. The breakthrough came when Rocket Lab switched from gas generator to closed-cycle design. This eliminated the overheating problems that plagued early development, creating engines that run cooler and more efficiently than Blue Origin's troubled BE-4s. 9 Archimedes engines provide redundancy. If one fails, the mission continues. At $2 million per engine versus $10 million for BE-4, the economics are clear. But the real innovation goes beyond engines. While Blue Origin stuck with traditional aluminum construction, Rocket Lab pioneered something revolutionary: the world's first large rocket built entirely from carbon composites. This wasn't just about materials, it was about completely rethinking how rockets work. Neutron's Hungry Hippo fairing system solves a problem that costs the industry millions. Traditional rockets throw away their nose cones after deploying payloads. Neutron's carbon fiber fairing opens like a giant mouth, releases satellites, then closes for reuse. This single innovation saves $10 million per flight while reducing space debris. The carbon composite construction offers 3 critical advantages that Blue Origin's aluminum design cannot match. First, 50% weight reduction means more payload capacity. Second, superior thermal properties allow unlimited reuse cycles. Third, automated manufacturing produces rocket sections in minutes instead of months. Rocket Lab proved this concept works through Electron's 68 successful flights. Every launch validates their material science, while Blue Origin's New Glenn struggles with basic structural integrity. These technical advantages created the foundation for Rocket Lab's next breakthrough. In March 2025, the U.S. Space Force made an announcement that sent shockwaves through the aerospace industry. Rocket Lab was selected for the National Security Space Launch Program, a $5.6 billion contract opportunity reserved for America's most trusted space companies. The selection criteria were brutal: proven track record, consistent reliability, and ability to meet critical deadlines. SpaceX and United Launch Alliance held these contracts for years. Blue Origin expected to join them once New Glenn proved itself. Instead, Rocket Lab leapfrogged past Bezos' company entirely. Defense officials revealed their reasoning through leaked internal documents. Blue Origin's delays had become unacceptable for national security missions. The Escapade Mars mission, originally scheduled for 2024 launch, was delayed until 2026 because New Glenn wasn't ready. Military leaders couldn't risk similar delays with critical satellite deployments. Rocket Lab's selection sent a clear message. Performance matters more than company size or funding levels. Their Electron rocket's monthly launch cadence proved operational reliability that Blue Origin couldn't match with years of additional development time. This contract validation opened doors to even bigger opportunities. August 2025 marked another turning point when Rocket Lab broke ground on Launch Complex 3 at Wallops Island, Virginia. This wasn't just another construction project, it was a direct challenge to the aerospace establishment. The facility specifications tell the story of Rocket Lab's ambitions. A 400-foot autonomous drone ship for rocket landings, nearly as long as SpaceX's Starship. Climate-controlled assembly buildings for rapid turnaround. Neutron's fixed landing legs eliminate the deployment failures that destroyed Blue Origin's booster. But the real significance goes beyond infrastructure. LC-3 represents Rocket Lab's transition from small satellite launches to direct competition with Falcon 9 and New Glenn in the lucrative medium-lift market. The timeline is aggressive. Facility completion by end of 2025, first Neutron launch shortly after. Just 4 years from initial design to operational capability. Compare this to Blue Origin's approach. New Glenn development began in 2012 with promised flights by 2020. We're now in 2025 with only one partially successful launch. The difference in execution speed reveals fundamental organizational cultures that extend beyond engineering. While Blue Origin burns through billions with minimal commercial revenue, Rocket Lab built a sustainable aerospace business. The numbers reveal why NASA and military customers are switching sides. Electron launches cost $7.5 million, but generate healthy profit margins through operational efficiency. 68 successful flights prove the business model works at scale. Blue Origin's New Shepard generates roughly $8 million per flight, but operational costs approach $5 million, barely breaking even for 10-minute tourist rides. The upcoming Neutron rocket targets the $67 million Falcon 9 market segment with significantly lower costs through carbon fiber construction and streamlined operations. Early customer commitments suggest strong market demand for reliable alternatives to SpaceX's near monopoly. Rocket Lab's financial discipline extends to development costs. Neutron's entire development budget equals what Blue Origin spends annually on New Glenn maintenance. This efficiency creates competitive advantages that money alone cannot overcome. The contrast becomes even starker when examining mission success rates. NASA's Escapade mission became the perfect test case for comparing these companies' capabilities. The goal: launch twin spacecraft to study Mars' magnetosphere during the optimal 2024 transfer window. Blue Origin promised New Glenn would be ready. NASA awarded the contract based on these assurances. Then reality intervened. Hardware failures, bent components, environmental violations, and repeated delays pushed the launch beyond the Mars window. The next opportunity, late 2026, with arrival in 2027. For a mission designed to advance our understanding of planetary magnetospheres, this delay wasn't just inconvenient, it was scientifically devastating. NASA officials privately expressed frustration with Blue Origin's inability to meet critical deadlines. Rocket Lab, despite Neutron still being in development, committed to Mars cargo missions by 2027. Their timeline actually beats Blue Origin's revised schedule for a rocket that supposedly flies today. The confidence comes from proven development processes and realistic project management. This mission highlighted a crucial difference. Rocket Lab underpromises and over-delivers, while Blue Origin does the opposite. Elon Musk's company dominates launch services, but even SpaceX is watching Rocket Lab's progress carefully. The reason isn't competition for heavy-lift missions. It's the threat to Falcon 9's medium-lift monopoly. Government and commercial customers increasingly value operational diversity. Relying solely on SpaceX creates single points of failure for critical missions. Rocket Lab's consistent performance offers the reliability alternative that Blue Origin promised but never delivered. The June 2025 back-to-back launches demonstrated cadence that rivals SpaceX's best efforts. 2 successful missions in 48 hours from a 1,500-person company shows operational efficiency that scales with proper management. SpaceX maintains advantages through Starship's massive payload capacity, but many missions don't require such capability. Neutron's medium lift capacity serves the majority of commercial and government requirements at lower costs through focused engineering. This market positioning creates sustainable competitive advantages that survive even intense competition. The symbolic timing of recent events couldn't have been more revealing about company priorities. While Jeff Bezos celebrated his $30 million wedding in Italy, complete with celebrity guests and lavish displays, Blue Origin launched another suborbital tourist flight. The contrast was stark. Bezos spent more on his wedding than Rocket Lab's entire annual research budget, yet the smaller company consistently delivers superior orbital results. Blue Origin's social media celebrated space tourism, while Rocket Lab announced breakthrough technical milestones. Industry observers noted this disparity reflects broader organizational focus. Blue Origin prioritizes publicity and ambitious announcements. Rocket Lab prioritizes engineering excellence and operational results. The difference shows in mission outcomes and customer satisfaction levels that determine long-term success. Rocket Lab's success proves that focused engineering beats unlimited budgets in aerospace development. Their achievements validate several critical principles that Blue Origin ignored: iterative improvement over perfectionist paralysis, operational excellence over publicity campaigns, and customer success over personal ego. NASA's quiet shift toward Rocket Lab partnerships signals broader changes in government contracting. Agency officials increasingly value consistent performance over company size or founder celebrity. The Artemis program requires reliable launch capabilities that Blue Origin's unpredictable schedule cannot provide. The space industry transformation extends beyond individual companies. Rocket Lab's success encourages other innovative firms to challenge established players through superior execution rather than massive funding rounds. This creates healthier competition that benefits customers through lower costs, higher reliability, and faster innovation cycles. This is exactly why Rocket Lab's victory over Blue Origin changes everything. It proves that execution beats unlimited budgets in the new space economy. NASA chose reliability over reputation, and that decision accelerates humanity's path to Mars, lunar bases, and beyond. What we're seeing is the democratization of space access. Small, focused teams can now challenge aerospace giants through superior engineering and consistent delivery. This isn't just about one company winning. It's about opening space to more players, faster innovation, and lower costs for everyone. Neutron launches in late 2025. Blue Origin will keep trying to catch up, but the real winners are the missions that will actually fly on time, the satellites that reach orbit as planned, and the space programs that can finally depend on their launch providers. The space race has evolved. It's no longer about who promises the most. It's about who delivers consistently. Right now, the underdog with 1,500 employees is beating the billionaire with unlimited resources. How do you think this will reshape the space industry? Will more small companies challenge the giants, or will Blue Origin finally turn things around? Hit that like button if this analysis opened your eyes to what's really happening in aerospace. Subscribe to Alpha Tech for more deep dives into space breakthroughs that actually matter. Ring the notification bell so you never miss when we expose the real stories behind the headlines. This is Alpha Tech, and we bring you the space industry insights that change how you see the future. Blue Origin just completed New Shepard 35, their return to flight after months of delays. But here's the reality check. While they celebrated this single suborbital mission, SpaceX averaged 90 orbital launches per year. The numbers expose a brutal truth. Blue Origin has flown 35 times in over a decade. Space does that in 4 months. We're comparing 11-minute space hops to sustained orbital operations that require 40 times more energy. Even worse, New Glenn, Blue Origin's orbital rocket, remains years behind schedule while SpaceX advances Starship development at breakneck speed. The gap isn't closing, it's accelerating. Let's dive right in. New Shepard 35 wasn't just another launch. It was Blue Origin's critical comeback after months of being grounded due to a flight anomaly. This mission had to prove their systems could still deliver flawless performance. The stakes were enormous, and deliver they did. The booster executed its signature vertical landing with mechanical precision. The capsule touched down safely in the West Texas desert, delivering scientific payloads from NASA's TechRise Student Challenge completely intact. For Blue Origin, this validated their methodical, safety-first approach to spaceflight. Here's where the story reveals its deeper truth. While Blue Origin celebrated this single successful mission, the broader competitive landscape had already shifted dramatically around them. To understand what's really happening, we need to examine the operational numbers that define success in commercial spaceflight. Blue Origin has completed 35 New Shepard flights over more than a decade, averaging roughly 3 missions per year. Each flight is planned, executed, and celebrated as a significant achievement. Meanwhile, SpaceX's Falcon 9 program averages over 90 orbital launches annually. That means SpaceX completes nearly 3 times Blue Origin's entire operational history every single year. These aren't just numbers. They represent fundamentally different business models. Every Falcon 9 launch generates substantial revenue from satellite deployments, International Space Station resupply missions, and crew transport contracts. More importantly, each flight contributes operational data that improves system reliability, creating what aerospace analysts call the operational excellence cycle. More flights generate better data, which increases reliability, which attracts more customers, which funds additional flights. This operational tempo difference reveals why Blue Origin faces such an uphill battle. Their missions remain special events requiring extensive preparation and celebration. SpaceX launches have become so routine that they barely generate media coverage.